You run the same coding job through Kimi K3 and Claude Fable 5, and one bill comes back 3 times bigger than the other, for nearly the same output. Kimi K3 is the open weight underdog. Claude Fable 5 is the benchmark leader. The question is whether the gap is worth the price. Test 1. Cost per million tokens. If you're running a coding agent at 500 million tokens a month and you pick the wrong model, that's a real budget conversation with your boss, not a line item you explain away. Input alone is $3 per million on one side versus $10 on the other, and before you even look at quality, the spreadsheet is already talking. I pulled the official pricing pages and the artificial analysis blended numbers. Kimi K3 comes in at $3 per million input, $15 per million output. Claude Fable 5 is $10 input, $50 output, exactly 1/3 the price across the board. The blended rate narrows it slightly to 3.3 ETH because Kimi's always-on reasoning burns extra tokens, but that's still a massive gap. Kimi K3 takes cost, and it's not subtle. At 500 million tokens a month, you're paying roughly $155 versus $3,850 for Claude Fable 5, and that 3.3 ETH blended gap plays out at real scale. Kimi K3 goes on the board first, 1-0. I know that cost gap because I've been inside these APIs long enough to watch it bite people who didn't check the blended rate first. Drop a comment if your team has felt this one. Test 2. Coding benchmark performance. Your agent fails a pull request on a real GitHub issue, and you have to explain to your team why you picked the cheaper model. SWE-bench verified is the independent test that actually catches that failure, and it's where the benchmark gap gets real between these two. On the independent val's AI harness, Claude Fable 5 scores 95.0% on SWE-bench verified. Kimi K3 hits 93.4%, which is actually the highest open source score on the board and 4th overall. Kimi flips it on front-end code arena, ranking number 1 globally at 1679, LO versus Fable's 1631, and it beats Fable on terminal bench too, though that one's vendor reported, so I'd weight it lighter. Claude Fable 5 takes coding benchmarks overall because the independent SWE bench number is the one you can actually trust, and that 1.6 point gap is real, just smaller than I'd expected given the 3x price difference. That ties it up, 1 win each. Test 3. Inference speed. You're in an interactive coding session, and the model takes 2 minutes to start its first response. One of the biggest problems I run into when using AI agents is turning their output into YouTube content I can actually use to market my product. That's why this video is sponsored by Subscriber, a tool that helps business owners connect their AI agents to YouTube and market their products without spending 10 hours every week creating content. You can connect Claude or ChatGPT directly to Subscriber. It then analyzes your business, website, and YouTube channel to help you create SEO-optimized video ideas, scripts, thumbnails, and even complete videos that actually match your brand. What I like most is that every week, Subscriber gives me a list of high-potential video ideas I can immediately execute, and it can even help edit videos for me, with or without my face, including videos like the one you're watching right now. It's easy to get started, and you can try Subscriber for free using the link in the description below. Now back to the video. That's a workflow problem, not just a benchmark number, and it changes how you actually use the tool day to day. The decode speed and time to first token tell very different stories here. Watch what happens when you split these two metrics. On raw decode, Claude Fable 5 runs at 63.2 tokens per second against Kimi K3's 40.8, about 55% faster on the first-party API. But Kimi's time to first token is 2.97 seconds, while Fable's max effort thinking mode clocks 126 seconds before it types a single character. So for quick interactive tasks, Kimi actually feels faster in practice. Claude Fable 5 takes speed on raw decode, 63.2 versus 40.8 tokens per second. And that's the number that matters most for sustained output and agentic pipelines, even though Kimi's faster start surprised me on simple queries. Fable moves ahead, 2 wins to 1. So Claude Fable 5 is ahead on benchmarks and speed. But we still haven't looked at context limits and deployment. And that second one is where the open weight question gets serious. If you're self-hosting or you need video input in your pipeline, the calculus changes pretty fast, and it could flip which model you actually pick. Test 4. Context and output limits. You're processing a 900,000 token codebase in one shot, and your model quietly truncates the response at 128K output tokens without warning you. The refactor looks complete, it isn't, and you find out 3 hours later. Context ceiling and max output are the two numbers that determine whether that happens to you. Both Kimi K3 and Claude Fable 5 give you a 1M token context window, so that part's even. Where they split is output. Kimi defaults to 128K, but you can push it up to 1M output tokens if you need it. Fable caps at 128K per request, full stop. Caching is also cheaper on Kimi, $0 or 30 Rs per million cache hits versus 1.0 Rs on Fable. The context window is identical, so neither model wins there. But Kimi's higher output ceiling only matters if your task actually needs more than 128K tokens of output in one shot, which is a pretty specific use case. For most coding workflows, you'll never hit it, so the practical edge here is Kimi's cheaper caching, not the output ceiling. Context limits is a tie. Same 1OM window, same 128K default output, and the caching advantage isn't enough to call a winner on its own. Score stays at Fable 2, Kimi 1, 1 tied. Test 5, deployment and modality. Your company's legal team says the model weights can't live on a third-party cloud, or your pipeline needs to process video alongside code, and suddenly the closed source option isn't an option at all. Open weights versus closed weights is a hard technical constraint that can take one of these models off your list entirely. Kimi K3's full 2.8 trillion weights are on Hugging Face right now, and it runs across 10 plus providers including Lambda, Fireworks, Together, and RunPod, hitting 298 tokens per second self-hosted. Claude Fable 5 is closed, no weights, locked to Anthropic's API, plus Bedrock, Vertex, and Azure. Kimi also takes video input, Fable doesn't. Kimi K3 takes deployment, and the open weight advantage is bigger than I'd expected going in, because self-hosting at 298 tokens per second is a completely different cost and control story than any API. That brings it to Kimi 2, Fable 2, 1 tied. Alright, so where does Kimi K3 actually win? Price, open weights, and front-end coding. It's 1/3 the cost of Claude Fable 5 on both input and output. You can self-host it on Lambda at 298 tokens per second. It ranks number 1 globally on front-end code arena at 1679 ELO, and it takes video input when Fable can't. Claude Fable 5 wins on raw coding accuracy and decode speed. On SWE Bench verified, it scores 95.0% versus Kimi's 93.4%. It tops the Deep SWE leaderboard at 70.0%, decodes 55% faster at 63.2 tokens per second, and has tighter enterprise reach with Bedrock across 30+ regions, Vertex, and Azure. GPT-5.6 Luna is the wildcard in this comparison, and I couldn't find sourced side-by-side output data to score it against Kimi K3 or Claude Fable 5 in a verified benchmark, so I'm not going to manufacture a win for it here. The directional data that does exist puts it in the same tier, but watch for independent reruns before committing budget. If you want the absolute best coding agent and budget isn't the constraint, Claude Fable 5 is your pick. If you want value, open weights, or self-hosting, Kimi K3 gives you 90% of the capability for roughly 1/3 the price. The honest edge case is heavy interactive coding, where Fable's decode, speed, and SWE Bench lead actually show up in your daily workflow. One thing the docs don't spell out, Claude Fable 5 has a safety gating behavior that silently reroutes flagged queries to Opus instead of Fable. So you can send a Fable API call and get an Opus response without knowing it. And there was a June 2026 outage tied to exactly this routing layer. Worth building a model check assertion into your pipeline. If cost is the main variable for you, the next video to watch is Kimi K3 versus DeepSeek V4 Pro versus GLM 5.2. Which is cheapest? Because that one runs the same blended rate math across 3 models all competing in the value tier. And the winner there is not who most people expect.